You've probably heard of the Bermuda Triangle, right? Well, it turns out space has its own version. It's this mysterious glitch in Earth's defenses, a known danger zone for our most advanced tech. Today, we're diving into what's called the South Atlantic Anomaly. But yeah, you could think of it as space's Bermuda Triangle. So, let's just stop and think about that for a second. When you picture space, you probably think of this huge, empty, pretty much uniform void, right? But what if I told you there's an invisible patch right over our heads that's just notoriously dangerous for anything that passes through it? I'm talking about a place where multi-million-dollar satellites just randomly reboot, where astronauts report seeing these weird flashes of light even with their eyes closed. A place so harsh that our most delicate, most expensive instruments have to be completely shut down just to make it through. And the crazy thing is, this place is real. It totally exists.
All right, so where did this whole idea of a Bermuda Triangle in space even come from? To get to the bottom of it, we've got to start by looking at the myth, at all this strange stuff that's been happening up there for years.
And listen, this isn't some sci-fi movie plot. Seriously, for as long as we've been launching things and people into orbit, there's been this one trouble spot that everyone knows about. It's this massive zone stretching all the way from South America over to Africa where things, well, they just go wrong. For decades, it's been a huge, expensive headache for NASA and every other space agency out there.
Okay, but it's not just a bunch of spooky stories and weird glitches. The truth is, scientists have had a pretty good handle on what's really going on for a while now. So let's peel back the myth and get to the science. Let's define what this anomaly actually is.
Its official name is the South Atlantic Anomaly, or SAA for short, and the definition here is super important. So picture this. Our planet is wrapped in these two giant donut-shaped belts of trapped radiation. They're called the Van Allen belts. And the SAA, well, it's basically just a spot where that inner belt sags, dipping way, way down, much closer to the Earth's surface than it's supposed to.
So, what happens when a satellite or a space station flies right through that dip? It's pure chaos. Electronically speaking, high-energy particles just slam into the spacecraft. This causes computers to glitch out, sometimes completely rebooting. You know, the good old turn it off and on again, but in space, which is not ideal. Instruments get swapped with what they call spurious data. It's basically just noise, useless static. And yeah, even the astronauts on the ISS get hit with a bigger dose of radiation when they pass through.
But that brings up the big question, right? Why? Why does this radiation belt dip down so low in this one spot? The answer, and this is pretty cool, is a flaw, a literal dent in our planet's protective shield.
So, you know our planet has this massive magnetic field, right? The magnetosphere? It stretches out for thousands of miles. It's our invisible force field, batting away all the nasty solar wind and cosmic rays the sun throws at us. It's, kind of the main reason we're all alive. But here's the catch. It's not perfect. It's not a nice symmetrical bubble. Our shield has a chink in its armor, a really significant weak spot. And that weakness, that's the source of the whole South Atlantic anomaly.
And it breaks down into a pretty simple chain of events that explains the whole thing. First off, Earth's magnetic core. It's not perfectly centered. It's a little tilted, a little off-kilter. That tiny imbalance creates this big weak spot in the magnetic field right over the South Atlantic. And since the field is weaker there, it can't push those Van Allen radiation belts out as far. So they droop down, closer to the planet. And boom, any satellite that flies through that area gets a direct hit from all that intense radiation.
So, it's pretty cool to compare the myth and the reality, right? On one hand, you've got the Bermuda Triangle, a legend filled with unexplained stories. But on the other, you have the South Atlantic Anomaly. This is a real, measurable thing. We can predict it. We know exactly why things go wrong. It's radiation. Simple as that. The nickname is fun for sure, but the science here is solid.
And this is the key takeaway here. This isn't just some neat, nerdy science fact. It has huge, real-world consequences for all the expensive, critical technology we have flying around up there.
Just think about the Hubble Space Telescope, one of the most important scientific instruments ever built. It spends about 15% of its time flying right through the SAA. And every single time it does, we're talking several times a day, the mission controllers have to shut down its most sensitive cameras and instruments. They literally have to blindfold Hubble so it doesn't get fried.
And it's not just our robotic explorers either. The International Space Station flies through it too.
That's why the ISS is built with extra heavy shielding, especially around the parts where the crew sleeps and hangs out. It's all to protect the astronauts from the extra dose of radiation they get when they're inside this cosmic hot zone.
So, to deal with this constant threat, engineers have basically written a whole playbook. They have all these tricks, right? They power down the delicate stuff during a pass. They build spacecraft with tougher, thicker shielding. They're super careful about scheduling spacewalks. You do not want to be outside when the station is flying through the anomaly. They even design special computers that are built to take a radiation hit and just keep on ticking.
And just when you think you've got it all figured out, there's a twist. Of course there is. This thing, this anomaly, it isn't just sitting still. It's changing. It's on the move.
Yep, you heard that right. Scientists are tracking it, and they've realized it's slowly drifting westward at about 20 kilometers or 12 miles a year. And get this, some of the latest data suggests the main weak spot might actually be splitting into two, creating this even more complicated, messy radiation zone for our satellites to fly through.
Which, of course, leaves us with a really big question for the future. I mean, we rely on satellites for everything now, right? GPS, weather, communications, the whole shebang. So, as this dent in our planet's shield keeps moving and changing, how are we going to adapt? What new challenges is this moving target going to throw at our future in space? That is a mystery that scientists are working really hard to solve right now.